So today we discuss basically the data structures questions, MCQ questions for WBTs. So the first question is the memory address of the first element of an array, that is called the base address, as we all know. And what are the second questions is two main features, measures of the efficiency of an algorithm. Of course, we know there are two type of measures, that is time complexity and the phase complexity. And in case time complexity, we know there is a big O, big omega, big theta notations, whereas space can be computed efficiently by actually calculating the memory that is needed. So in the next questions, what are time factor when determining the efficiency of an algorithm, that is measured by counting the number of keys operations. The fourth question is the base factors that I already discussed, that when determining the efficiency of algorithm, that should be measured by counting the maximum memory that is needed by an algorithm. The question number 5, which of the following cases does not exist in the complexity theory? Of course, null cases, because we know the best case, average case, and worst case has already been there. Null case is not there. The worst case occurs in linear search, of course, when the element is present in the last locations, or it may not be present. So the item in the last element in the array, or it not there at all. The complexity of linear search, since if there are n elements, and we know, and in worst case, that means it will actually compare all the elements, n elements, and then they can decide that whether the element is present or not. If it is not present, then that is the worst case, and it will take order of n. And also the questions comes in that fashions, that what's in the complexity for an unsorted array, so it should be order of n because it is linear search. But if the elements are given sorted, then the complexity of binary search, and it is order of log n, which is in questions number 8. Questions number 9 will tell you that which of the following data structure is not linear data structure. Of course, we know, and there are linear and non-linear. In case of linear data structure, there are arrays, there are linked lists, there are stacks and queues, and in case of non-linear data structure, there are trees, there are graphs, tables, set, like that. So in that case, that none of this, because these both are linear data structures. The operations of processing each element in the list is known as, of course, traversals. We know if we want to traverse, that means we are processing each element. Now in the questions number 11, the linked lists are best suited, of course, when in case of the problem. But disadvantage of an array is insertions, deletions, updations. But if we use the data structure that is constantly changing, then we can use the linked list. So option B is correct. And we know that the memory address, you can actually know that if we want to find the address of an array of 5 locations, then it should be pointer by using pointer is the base address, and we have to multiply it by 5 with the corresponding data type. That means if the array will contain integer data type, and depending on the architectures, the size of the integer is determined. If it is take 4 bytes, then it should be multiplied by that and plus base address. So in that it will be like the options A is correct. Now there is a question from hashing, that if h be any hashing functions and is used to hash n keys into a table of size m, and the size of the keys is less than the size of the table, that means most of the table is cell of the table is vacant. So expected number of collisions, we know there is a measurement which is called load factor, which is n by m, where you can say in is number of elements, and m is the size of the table. Herein is less than m, that means it should be less than 1. So now if the question number 14, if A be the adjacency matrix of a graph G, ijth entry. What do you mean by that? If we take this is a matrix, if it is an adjacency matrix, there is a number of rows, and there is a number of columns, and as we know that is given the shortest path of k is from the vertex vi to vertex vj. That means if this is a vertex vi, that means we know, if we just consider a adjacency matrix, there are vi, vj, This is also VI like that, and this particular point is nothing but the shortest part between vertex VI and vertex VZ. Now question number 15 actually comes from the operating system, but we know that that will collect the free memory space from contiguous block allocation, that is garbage collections, and we know not the garbage, this is garbage actually. And we know that in Java there is automatic garbage collection, and in C we know this is a programmer responsibility, because when you allocate the memory by using dynamic memory allocation, we know there are some functions like that. There are malloc, there are calloc. These particular functions, by using these particular functions, we are allocating the memory. And in dynamic allocations of memory, it will be taken from the heap sections of the RAM. So this is very costly section, so it is a programmer responsibility to free the area after doing the operations, but automatically it is not done, it is done by Java. So in C there is no automatic garbage collection. So that question is automatic garbage collections. So now the thing is, you have to sort a list L consisting of a sorted list that is followed by few random elements. Which of the following sorting mechanism? Of course the answer is insertion sort. If you just think about the insertion sort, that means a set of cards, say the set of cards are randomly placed in the table, and you are pick up a card from that particular table, and you have to place in your hand in a particular position. That means you are already been sorted when you place it in your hand. So that's why that is the mechanism of insertion sort. So b3, we know that b3 that may be another tree, and you cannot say about that very deep and narrow, very wide and shallow, and very deep and very wide. So options is D. Now the question number 18, a technique for direct search, of course hashing, because we know in case of hashing, for searching it will take order of 1. Now if we move to the questions number 19. So in case of questions number 19, if a node having two children is deleted from a binary tree, it is replaced by. That means you have to delete a node having two children. A node having two children is deleted from a binary tree, so it is replaced by, of course, in order, you can say about in order successor. That is option is in order successor. The searching technique that the order of one we already discussed, it is nothing but the hashing. Now question number 11 is the number of interchanges required to sort 51624 in ascending order using bubble sort. And of course if we know about the bubble sort, so that means this is 5 1, this is 6, this is 2, this is 4, and for pass 1 we know that this 5 is greater than 1, so each 1 and 5 is interchange, and then this is not interchange because 6 is greater than, again 6 and 2 are interchange, that means 1 5 2 6 4, and again 1 5 2 4 6 is interchange. So the question is the number of interchanges required to sort 51624. So again that is the, you can say that number of interchange, that means this is the first, you just need to interchange this one, this is 2, this is 3, and again you have to use the pass 2, and you will find that the number of interchange that is needed is nothing but this is true. Then in the second pass you can say that 1 and 5 that will not interchange, then 2, and that means 1 2 5 4 6, that is the one number of interchange, and this is 1, this is 2, this is 3, this is 4, and then this 1 2 4 5 6, so this is number of 5. So we need that, in that particular case we need 5 interchanges. So the postfix for a string in the actual string, Postfix notations, as we know that if a this is an infix, if we this is a prefix, and postfix means this. So in that particular case, the postfix for a string is so actual string. That means you have to write the corresponding infix expressions. So you can say, you can calculate it, and that is the particular options that is correct. If we make it postfix, we will get the answer. So that is the question number 22, and question of the postfix form of the expressions this, and you can also make it postfix. That means AB star, then CD star, minus E, and all those stuffs. If you just complete the thing, then you will get the answer is A. Now in questions number 24, the algorithm, the question is the algorithm that will efficiently sort an array that is nearly sorted except for the interchanges of some adjacent part of numbers like 1, 3, 2, 5, 4, 6. Then what kind of sort you can use? Of course, when it is nearly sorted, then we can use the concept of, you can say, bubble sort, because you know bubble sort with flag variables. If the array which is given is already been sorted, then if we just apply the bubble sort, then there is no interchanges, and if there is no interchanges, then we can declare in order of n that the elements are already been sorted. So in a balanced binary tree given below, how many nodes will become unbalanced when a node is inserted as a child of the node G? That means uh, if you just insert it we not, in that particular case we know that height balance T means the, if we say balance factor, that is the height of the left child minus height of the right child mod. That means if the value is 0, minus 1 and plus 1, then you can say that is balanced. So in that case, maximum length 1 2 3, this is 1 2, that means that should be left minus right. In this case, left is 2, right is 1, that is 1, that is left is 1, this is 0, this is 0, and in that particular case plus 1, like that. Now if you can insert a node here, say P is the node, that means some nodes you have to modify that, that is 1 2 3 4, but that is only 2, that means that is plus 2, 1 2 3, that is also plus 2, that is also plus 2. That means what will happen, the balance factor will be changed for A, B and C node. So coming to the options, the answer is B. That means there are three nodes that balance factor has been changed. So now next question, what is the time required to insert an element in the stack with linked list implementations? And of course it will take order of 1. It will take order of 1. That is the answer of options, questions number 26. And in 27, which of the following is false? So we know that which of the following is false, that the options are every tree is a bipartite you can say, and a tree contains a cycle, a tree with n nodes contain n minus 1 edges, a tree is a connected graph. So the option C is a tree contains a cycle, that is a false. So for an undirected graph with n vertices and e edges, the sum of degree of each vertex, that is a simple straightforward questions, and that is 2e. So the thing is that in questions number 28, 29, I think so, So in questions number 29, in worst case the quick shot has order of complexity, and of course coming from the options it is order of actually n squared. To be precisely, you can say the order of n squared by 2. A full binary tree with 2n plus 1. So what does it mean by full binary tree? Full binary tree, that means like that every node has full number of children. So like that. And if it is a complete, then that means it will be occupied from the left hand side. So in case of full binary tree with 2n plus 1 nodes, that will contain, of course, that will contain 2n leaf node, because you can find 1 2 3 4 5 6 7. There are 7 nodes and the leaf node 1 2 3 4 4. That means 2n plus 1 is equals to 7, and then you can find the value of n is 2n plus 1 nodes that contains, you can say, then you can say that a full binary tree that will contain the n non-leaf nodes, you can say, because there are n value is 3, so only there is non-leaf is 1 2 3, so n non-leaf nodes. So this is the questions number 30. Questions number 31, which two of the following are equivalent for an undirected graph G? G is a tree, or there is at least one path between any two distinct vertices of G. So you can say that, and G contains no cycles and has n minus 1 edges, and G has n edges, so are equivalent for an undirected graph. Of course, G, you can say, is a tree. So, and of course G contains no cycle and has n minus 1 edges. So options B is correct. So if a node in a binary search tree has no children, I think so, so then its predecessor in order predecessor has no right child. So linear list of element in which deletion can be done from one end and insertions can be placed only at the other end is known as, you are always familiar with that type of data structure, that is nothing but Q, where we use two pointer, one for insertion, one for deletions. What is the postfix from of the following prefix expressions? And of course if you can do it, it comes out like that. Option A, a full binary tree with n leaves that contain, we already going through the so in the, it should be 2n minus 1 nodes. So width is better than if 2n plus 1 nodes are there, but since it is given like that. Which of the following sorting algorithms does not have a worst case running time of this? That means does not have. So we know that insertions are, of course, the worst case is order of n square, but in case of merge sort, we can say the three worst case, best case, and always order of n log n. So an undirected graph G with n vertices and e edges is represented by adjacency list. And what is the time required to generate all connected components? And of course, you are using adjacency list, so it will take order of e plus e. That means e is the number of edges and e is n is the vertex. The propositional formula that is given by the tree. And of course, this is the one of the, you can say, expressions tree like that. It will work like that. So in that particular case, you can say that, of course, you can say that is not x1, and if it is not x1, then it is connected to v, that is or, and you can like that not x1 or x2, that particular node, and this is also not x1, this is x2, and then it is ending. So from that particular figure you can find that the options is, of course, that is C. You just find this, that not x1 or x2 and not x1 or x2, like that.